Students, now we will see the second example in trusses. The previous example that we had seen, that was a very simple example and that was a single triangle truss. Now I will show you a truss wherein we have different triangles attached to that and the number of forces are more, number of members are more, so we can see how to solve that type of a truss. Now you can see that this truss is having more number of members and the forces acting on this is more. Now, the first step that we have to do, you might be remembering that the first step that we need to do is check the stability. What are the number of members? Member AB 1, 2, 3, 4, 5, 6 and 7. We have to find out the number of joints as well now. Number of reactions. Since we have a hinge support and a roller support, the number of reactions will be 3. Now we can see that my right hand side, that is 2j minus r, is equal to my left hand side, that is the number of members. So that means this is a perfect truss. Now students, the first thing that we have calculated, that was stability criteria. In the previous example, you might remember that we need to calculate the support reactions that we have. Now the support that we have over here at joint A is hinge support and over here is a roller support. What we need to do is, we need to draw the FBD and then find out the support reactions. Now FBD is something that you can draw easily. So I won't be doing that, I'll just show you the calculation part. Apply conditions of equilibrium to find out the support reactions. Now what I have done is I have written the moment equation. The length of each member I have clearly mentioned over here is 1 meter. Now I need to find out the support reaction at D. So doing this calculation, I can find out VD. Now if I put this value in this summation Fy equation, I can find out value for VA. Now we have got the support reactions. The vertical support reactions are 3.25 kilonewton in the upward direction at D. Then I'm having vertical reaction at A, which is again in the upward direction, and that is 2.75 kilonewtons. There is no horizontal force, so the horizontal reaction, that is HA, will be 0. Now the next thing that we have to do is we have to find out the forces in each member. Now as I said, the first thing that we need to check is the number of unknowns at a particular joint. Now, for example, if I take joint A, now what is going to happen at joint A? There is no horizontal reaction, so HA is 0. I'm having a vertical reaction which is known to me now, and that is 2.75 kilonewtons. So I can put that value over here and I can find out the forces in member AB and AE. I have two unknown forces. What if I take joint E? At joint E, I have this force ED or DE, you can call it as the unknown force. CE, again the unknown force. BE, again the unknown force. And AE, even this is the unknown force. So at this one single joint, I have four unknown forces. So the number of equations that I can make is 2, that is for summation fx and summation fy. But what about the other two unknowns then in that case? I won't be able to solve this type of a joint. So what I will do is I will start with a joint wherein I have only two unknown forces. So now I will start with joint A. Now, what I've done is I've drawn the FBD for joint A. At joint A, I'm not having any horizontal reaction. The reason for that is HA in this case is 0. So even if I show over here as HA, this becomes 0. Now, applying the conditions of equilibrium. Now, what I can do in this case is resolve this force AB and write it in the equation form. In this case, you can see that the force in member AB is coming out as negative. So we can say that the nature of the force in member AB is compressive. Now, what I can do is I can find out the force in member AE if I substitute AB in the equation summation Fx equal to 0. Now, what I've done is I've put a negative sign for the force member AB. The reason for that is the answer that I have got for AB is negative. And over here, I have assumed AB to be positive. Now, since it is a compressive force, the direction of this force changes. It turns downwards. So, if I draw this force member AB, it becomes like this. And if I resolve it, it goes like this. So it has to be negative. Now you can see that force in member AE is positive and I can say that it is a tensile force. Now, using this joint A, I have calculated force in member AB and AE. You can see that this member I have already calculated, that is AB. This I have done, AE I have done. Now I will move on to next joint, that is say joint B. If I move on to joint B, what is going to happen in that case? How many unknowns do I have? Force in member BC is the unknown for me. Force in member BE is again unknown. But I have already calculated force in member AB. So that is known to me. And this 2 kilonewton force, even that is known to me. So again, I'm having only two unknowns, that is for force in BC and force BE. Now, we know that the force in member AB is compressive. So we have to change the sign again. So what I can do is, I can show this force as a compressive force and resolve it accordingly, or I will take it in the outward direction, that is, all the forces originating from a joint are assumed to be tensile. So what I can do is, I can take it tensile and solve it. In that case, I will put a negative sign. If I am drawing it as a compressive force, that is the force moving in towards the joint, though in that case, then I will say that the force has to be resolved accordingly, so force will be positive. Now, in this case, I will take it negative because I'm assuming all the forces acting are outwards from the joint. Now, I know the force in member AB. So I can directly substitute that value over here. That value happens to be 3.17 kilonewtons. Since I have taken the force to be tensile, I need to put a negative sign for that as well now. Since in this case, the force was acting in the negative direction, I have written the negative sign for that. But now what happens is, the force ka value happens to be negative. So I have to put minus 3.17 cos 60. So if I calculate this, the value that I'm getting for that force in BE is positive. So I can say that it is a tensile force. Now, if I put this value BE in the equation of summation Fx, I can find out the value for force BC. So after solving this force, I can find out that the force happens to be negative, and I can say that the force is compressive. So coming back to the original truss, now I can see that clearly I have solved for force BE and force BC. Now what is remaining is force EC, ED and CD. So what I can do is, I can move on to next joint, that is joint D. If I take joint D, what happens in that case? The vertical reaction, that is known to me. The force in member ED is not known. The force in member CD is again not known. So I have only two unknown forces in this case. So I can take joint D and solve it. Now we can see that the force in member CD is coming out as 4.33 kilonewton, and that is negative. So we have to say that it is a compressive force. Now, if I put this value in the equation of summation Fx, I can find out force in member ED. So what I can do is, if ED happens to be positive, I can cancel out the negative sign. So it is a tensile force of 2.16 kilonewtons. So now coming back to the original truss, you can see that I have calculated force in member DE and CD. Now what is left out is the force in member CE. To solve this force member, I can take either joint E or joint C. Now in this case, I would prefer taking joint C because the number of forces at C are less as compared to the number of forces at joint E. It becomes summation Fy equal to 0 minus FCE sine 60 minus FCD sine 60 minus 3 equal to 0. Now, in this case, I know the value for force CD. I have calculated the value as 4.33 kilonewtons, and that is compressive. So you have to take care of the sign in this case. You have to put a negative sign for the value now. So in this case, I have got the value for force in member CE to be positive, and the value is coming out as 0.867 kilonewtons. So I have done this member as well. So in this way, I have calculated force in all the members. So now the last step that I need to do is I need to tabulate all the results that I have got. Now, the force in member A, B, we have got it as 3.17 kilonewtons, and that is compressive. We have got the force in member AE as 1.59, that is tensile. Now we have to find out force in member BC and BE. Here you can see that the force in member BC is 2.03 kilonewtons, and that is compressive. Force in member BE is 0.87 kilonewtons and it is tensile. Now, since the magnitude of all the forces is in kilonewton, I can write in common over here as kilonewton. Force in member ED we have calculated to be as 2.16 kilonewton and it is tensile. Force in member CE is 0.867 kilonewton tensile. And lastly, the force in member CD is over here and it is 4.33 kilonewtons compressive. So in this way, we can say that the whole truss has been solved and the force in each member has been calculated. So friends, I hope that this sum has helped you in solving the trusses example, and we will take more examples in the next lecture.